I do want to thank certainly Pam Ismail for her presenting today. She's working, as a spotlight. She's working Plant Protein Innovation Center, which really started a couple of years ago. They've had their second conference this year, earlier in the year, which was great. Had a very large turnout and really generating a lot of excitement. And one of the issues, as I look at it, is that perspective that if you look globally at nutrition and health and hunger issues, one of the limiting nutrients of the four macro things is protein. And I'm sure Pam will talk about this, but the impacts that has on early childhood development, on brain development, neurological development issues in general. And so and then of course the environmental aspects of plant-based proteins is really a place where, as we're linking together work agronomically on new crop development to trying to serve nutrition, spans really the entire scope of what the college does and the environment natural resources side. And so it's really an exciting project that Pam has been leading and center. And so it's great to have her presenting today. And so with that, just wanted to make that link across it. Thank you all for joining us. And I will introduce Pam Ismail, who's a professor in food science and nutrition and the director of the Plant Protein Innovation Center. So with that, Pam, welcome and thank you for doing this today.
Yeah, thank you, Brian, for the introduction and for the opportunity today to share with you guys some of the work we're doing in this space. My story with protein started when I did my master's research, and I didn't realize at the time that the protein is going to be such a hot topic a couple of decades afterwards. So I should remember to send a note to my master's advisor and thank him for giving me a protein project. Today I'm going to share with you the importance of proteins, a little bit of an overview about the demand and trends, and then move on to talk to you about the initiative of the center and the type of research we are doing. So to start off, the demand for protein, whether it's animal-based or plant-based, is steep and increasing. And for our current population of 7.8 billion, the demand tops 200 million tons. And we talked on specifically about protein ingredients that are used in different products. The global demand is projected to reach about 7 million tons by 2025, accompanied with a market revenue of about $70 billion by that year, and we're growing at least 8% annually. Of the protein ingredient market, plant proteins specifically account for 40%. So if we look at the reasons for protein demand and the rise in protein demand, we look at population growth. So we're increasing in population growth, so that means more demand for protein in general. Also, we see socioeconomic changes, so rising income, increased urbanization. Of course, we see also aging population where protein is associated with healthy aging. And consumers are becoming more aware of the role of proteins in a healthy diet, at all stages of development. And if we look at developing versus developed countries, in developing countries, it's projected that the demand for animal-derived protein to be doubled by 2050. Whereas in developed countries, alternative protein demand is increasing. So let's look a little bit about why the interest in alternative proteins, and specifically plant protein, is on the rise. So we have different perspectives, and if we look at consumer perspective, they are now more aware of the environment issues, and they're looking for sustainable sources. So sources that have a low greenhouse gas production and low impact on global warming. So they are very aware of that issue, and they're looking for sustainable sources to protect the environment. Also, there is the issue of animal welfare that some consumers are being concerned about, and also knowing and associating plant-based foods in general with healthy diet. And we see also an increase in vegetarians and flexitarians. So who are the flexitarians? It's a kind of a new term that we hear often. These are people that would eat animal protein, but they have preference for plant-based foods. So they would prefer more plant-based, but occasionally they will have in their diet animal-based protein. So as flexitarians, they would be looking at plant-based proteins to increase in their diet. Also, there are rising incidences of allergenicity, so people are looking for alternative proteins that they are not allergic to. So that's the consumer perspective, and if we look at producer perspective, so they definitely want to address the consumer demand. So they want to give the consumer what they're asking for, while also making profit by seeking lower costs. So plant protein could be of a lower cost for them to work with than traditional animal-based protein. Also trying to find a unique and competitive place in the market, how they can compete and still make profit, and also valorizing byproducts. So if we look at oilseeds, for example, as in the case of soy, 50 years ago or 70 years ago now, soy was mainly used for its oil. And then over the years, they discovered that the meal is rich in protein that could be good not just for animal feed, but also for human consumption. So valorizing these byproducts that they can get from oilseeds other than soy nowadays, that's canola, sunflower, and other incoming oilseeds. And also there's the notion of clean label, where the consumer, what is clean label? The consumer is looking for an ingredient list that they can understand. It's not very lengthy. They can understand what is put into that product. So going away from chemical ingredients and trying to replace it by functional proteins that would produce the same physical and textural outcome as well as flavor. So when we talk about that, what does functional protein mean? Okay, I'm ahead of myself here, but again, I want to emphasize the population growth as well, and having 10 billion by 2050 that we need to feed and ensure they have abundance of protein sources. But again, going back to that functional protein that I was talking about, is what do we mean by functional proteins, and what is the role of proteins really in our food? So, of course, first of all, we think about nutrition and the contribution of protein to nutrition. And we all know that we need it. It's a requirement. It's a required macronutrient in our diet, where on average we need about 50 grams per day, or more accurately, a gram of protein per kilogram of body weight. But this 50 grams of protein shouldn't be any protein. It should have our essential amino acids. And it also should be digestible. So the way to monitor that is by looking at PPIC, which is the protein digestibility corrected amino acid score. And a score of 1 means, in simple terms, it has the essential amino acids required in specific amounts, as well as it can be digested and amino acids can be absorbed. So a score of 1, you can see mostly all animal protein as a score of 1. And then if we look at the plant sources, soy protein has very close to 1 PPIC, so it is almost a complete protein and a go-to plant-based protein with regard to nutrition. Other role of proteins in terms of physiological function, we look at muscle growth, which is very common for athletes, and also regeneration of muscles after an exercise. That's a very important physiological role of protein, and specifically the amino acids that are branched chain amino acids like leucine, isoleucine, and valine. If they're present in the protein, then they contribute to muscle growth and regeneration. Of course, reduce muscle deterioration in aging population, or preventing muscle deterioration in aging population. As protein has been associated with weight loss and also a good metabolic health. A protein carries certain sequences within them. We call them bioactive peptides, certain sequence of amino acids that have physiological function and can potentially reduce hypertension, act as antidepressant or promote satiety even. So that's from a nutritional physiological perspective, but then you want to know what other role of proteins, why are they added as ingredients in different food products? So they have a physical function that relates mostly to texture. So you have the water binding, water holding capacity in relation coagulation that is important in food systems like a jelly, where it's as low as 1%, so 1 gram in 100 grams. So for the 99% is moisture or sugar in there. So just that 1% protein gives you that texture, three-dimensional texture that holds the water. And also another application would be the tofu application, production of the soy-based meat analog, for instance. Solubility is important for ready-to-drink beverages, where you have these clear beverages that are acidic and high in protein. They are the go-to for muscle regeneration and muscle building. So you need that protein to be soluble in order to stay dispersed in that system. Emulsifying foaming, if you look at the ice cream, is an emulsion and a foam system where you are entrapping fat in an aqueous medium, and also you're entrapping air, so you need an emulsifier and a foaming agent such as protein to entrap that. So if you want to have a plant-based ice cream, you want to make sure that the protein is functioning in that way. Also in cake production, it's the batter is a mixture of, or is a foam and an emulsion at the same time. And you have the viscoelastic properties that are needed for bread products, different types of bread, pita bread or loaf bread or baguette or what have you. You need that characteristics of the protein from wheat form that viscoelastic property. So proteins are important for nutrition, for texture, and also they have an impact on flavor, which I'll touch upon in a minute here. With these roles, they are incorporated in different food applications, but we do have trendy applications right now, and also for calling for plant proteins to be used in these applications. So if we take the meat analogs, for example, this is a growing sector in the market, and it's projected to reach about 1/3 of the market by 2050. So it's huge, it's growing, and we're not only looking for plant-based meat analogs that represent a patty. Consumers are looking for that texture as well, like chicken-like texture or fish-like texture, so but using plant proteins. Protein beverages, the ready-to-drink as well as the shakes. But if we look at the ready-to-drink beverages, this is also another growing market, estimated to reach about $2 billion in 2025. Dairy analogs, so you have the replacement of milk and replacement of cheese, plant-based cheese, plant-based yogurt, plant-based ice cream. All of these are also trendy applications. Protein bars, extruded products, and snacks, also looking to replace animal-based protein with plant protein. But there is a caveat. So when I was hearing an industry pitch a year or two ago, they were specifically pitching for plant proteins to go into these products, but asking for alternatives to soy and gluten. For many reasons, some of it includes GMO, soybean, GMO, allergenicity, sensitivity to gluten. So we are looking for alternatives to soy and gluten, although they are both plant-based. So the alternative protein list is just huge and growing. And a lot of it is plant-based, but we also have the non-plant-based alternative as well. So if we look at the plant-based, the leading category is pulses. So the pulses, within it, we have the peas, chickpeas, lentil, beans, all sorts of beans. But the leading among them is peas. So we'll give an example on that in a minute here. Oilseeds is another category that is gaining traction. So within oilseeds, other than soy, we have canola or rapeseed, and then sunflower. These are both huge and used for oil production, but again, the meal is rich in protein. Camelina and fenugreek are new crops that are being developed here at the University of Minnesota under Forever Green Initiative. And these are crops with environmental benefits. And also they are oil seeds, so that means they're high in oil, high in protein. Other categories that not necessarily plants, you have the single-cell protein produced from yeast, algae, and fungi. You have the lab-grown protein to culture cells that mimic meat texture. Insect protein is another category that is growing. And then looking at other plant sources, hemp now is legal and also it's gaining traction. Corn, potato, oats, peanuts, almonds, any sorts of nuts, and also other sources of grains that could potentially be rich in protein. So I'm just going to focus on a couple of examples here, and starting with peas as a trendy source of protein. It's really catching momentum, and for many reasons. If we look at the benefits of growing field peas, specifically yellow peas, these are the ones that are used for protein production. They have a short growing season, so that means they can grow and nourish soil and can be incorporated in crop rotation. So they nourish the soil, they're legumes, so they fix nitrogen, and by that they improve the nutrient level of the soil, so that when we plant annuals, the soil is rich with nutrients. Other advantages include that it's currently non-GMO and it has low occurrence of allergens. And I say that with a caution here, because with like 50, 60, 70 years ago, soybean allergy was not among the crop-based allergens declared by the FDA. But the more we have soy protein in our food application, more exposure, we got the allergenicity going. And that's why I say it with cautious here, because with more exposure, it's bound to happen. But for now, it is attractive because it is not among the main allergens, and it's non-GMO. And it carries some nutrition, and 2016 was declared as the International Year of Pulses due to the significance of these beneficial properties. So just to illustrate in the market what's happening in terms of protein products that are launched, we see that over the years we are seeing a decline in soy protein-based launches, whereas pea is seen an incline. So it's increasing. It's trying to catch up, but it's not yet there due to many, I won't say many, but several disadvantages. If you look at those, it does have a lower PDCAS value, so it's not 1, it's lower, around 0.6 to 0.8, the score, compared to soy protein and animal-based protein. It does have inferior functionality if I just want to compare it to soy protein, and I'll give you an example about that in a minute. It does have flavor issues yet, so the crop carries endogenous flavors, carries enzymes that might result in off flavor during production, and this is still an area that needs to be addressed. Starch and fiber as co-products. We're thinking about pea flour is about 20 to 25% protein, and the rest is starch and fiber. So when you produce protein, you have other products that we need to find market for as well. Otherwise, it will be a loss. So looking at functionality, just to give you an example of where pea protein is considered of an inferior functionality, when we compare it to soy and whey protein. So if you look again at that clear beverage, it's formulated with whey protein, because whey protein can be soluble and give you a clear solution. That means your beverage is clear, and clear beverages are desirable just because they look nicer in their packaging material and see-through package. And also the protein remains soluble for a longer period of time. So if we look at solubility, at pH 3.4, which is the acidic pH of these ready-to-drink beverages, you look at whey protein, wow, it has the highest solubility, 100% soluble. It is considered the golden standard for such beverages, but we're looking for plant protein alternatives. So if we look at soy, solubility is not great, but it's about 20%, so maybe your inclusion level will be a little lower to get to to a beverage that is acceptable. However, if we look at pea protein, it is really inferior in solubility, less than 10% soluble. So this impacts inclusion level. So we can't have the higher protein to make the protein plain, because the protein will sediment over time or even gel over time. Even when you shake the beverage, it won't go back in solution. Some tea-based beverages, they write on the package, shake. No, really shake. It's actually written like that on the package. But sometimes, even if you shake, it just formed a gel and it won't go back in solution. That's why shelf life would be short, and short shelf life is not desirable. That, not to mention flavor issues as well. So with higher inclusion, you get that creamy flavor as well, which is a problem. So in regard to oil seeds, I'm just giving you again an example of another category. And here we have, like you said, the canola and sunflower, as well as the newly being developed as of now, camelina and honeycrisp. So they are oil seeds, so they're also high in proteins. So you press the oil out, and then you end up with a meal that is rich in protein. That's where we want to valorize that. As of now, it has low occurrence of allergenicity. It does have, some of them have environmental benefits, specifically camelina and honeycrisp as short-season crops that can be introduced in crop rotation, and also have environmental benefits in terms of enriching the soil and preventing soil erosion. Looking at PPIC, canola protein specifically is similar PPIC to soy protein, so there is some benefit there as well from a nutrition perspective. Now, disadvantages is looking at the meal after you extract the oil. It's a very complex matrix. It has the fiber, and the protein is entangled in that fiber. So getting that protein, producing an ingredient, is potentially a challenge, getting that protein out of that matrix. Inferior functionality, because when you press that oil and get every last drop of oil, you go through a lot of processing that is potentially damage your protein, and if the protein is damaged, the functionality is sacrificed. Flavor issues, high in polyphenols, you get the bitter notes, you get oxidation, that would cause flavor and color issues. Some crops are high in glucosinolates, and these have the sharp flavor as well. But some extraction technologies can get rid of glucosinolates. So we have these, I just gave you two categories as example. There are other categories, but we do have these potential plant protein sources, but they come with some challenges that we need to address and understand. How can we utilize those alternative proteins and replace or combine them with traditional protein ingredients and deliver optimal nutrition, functionality, and flavor? And I call these the three pillars, because, you know, if you don't have good PPIC, then you cannot make a claim on the label, then potentially you cannot use that protein. And if it has good nutrition, but it's not soluble, it doesn't gel, it doesn't form your emulsion, so functionality is poor, then you cannot utilize it in different food products. And if it brings with it a package of flavor that is off flavor, then it's also potentially a challenge, and it's a big challenge. If it doesn't taste good, nobody's going to eat that product. So I call them the three pillars, because we really have to have a nutritious, a functional, and not a killing flavor protein ingredient. So we need to understand how we can achieve that. Also looking at these viable and industry feasible extraction procedures to produce these ingredients to be used. So whether it's wet process or dry process, what unique processing technologies we can utilize to produce functional protein ingredients from these novel sources. Sometimes these novel sources or these proteins have unique characteristics, so we can have unique applications of high value, so we need to discover that. Also, there is this issue of crop diversity. So often we are breeding to increase yield, to have environmental benefits, looking at agronomic feasibility, but we really need to breed as well for protein quality. So we need to investigate crop diversity in terms of different varieties and lines and environment of growth, and also breeding approaches to enhance protein quality traits, whether it is nutrition, functionality, or reduction of flavor. And also, when we're developing these new crops, we also need to make sure that we have a system that can provide abundant and sustainable supply. So lots to work on, lots to figure out. So we need to do more research in this area. And with conversation over the past couple of years, or even more with industry, so there is a need to basic research in this area in order to bring plant protein ingredients to the market and be able to utilize them. And hence the Plant Protein Innovation Center is the platform that hopefully will provide the knowledge needed to innovate in this space. So we started the PPIC, or Plant Protein Innovation Center, which is the first in the nation of its kind. We have started a little over a year and a half. So our inaugural was November 28th of 2018. We had right from the start spark of interest and a lot of representation from companies that attended our inaugural. Lots of good discussions about research topics and priorities. So what's our mission really is, the mission of the center is to bring together minds of from interdisciplinary perspectives where researchers and industry can partner together to deliver to the supply chain new, and not just new plant protein ingredients, but nutritious and functional and ingredients, as well as new products. And we want, in order to do that, we want to work all the way across the whole chain, from breeding and genetics to processing, formulation, and marketing. So we want to start from the beginning all the way to the consumer. Our approach really is industry-identified challenges and opportunities. So we want to address those challenges and opportunities, and we want to develop the research, the basic research, the interdisciplinary research that will lead us to innovate in this space. So with a lot of discussions with industry and researchers over the past couple of years or a little bit more, we came up with 3 categories for research. At the production level, where it is related to breeding, sustainability of supply, and crop diversity. And also another category that is focused on processing and formulation, where we do research looking at extraction methods for ingredients, unique processing, what do we do with co-products, developing food systems, and high-value end use. And then in terms of the last one, which is actual application, we want to make sure that we have the research that will lead us to acceptable flavor, functionality, and nutrition in our final product. So how we're going to approach that is really coming together, working together to grow this area of research. And if we look at the University of Minnesota, we're really the home of numerous experts in relevant fields. And it's not just food science field, it's really encompassing lots of different expertise that we need to bring together for this particular purpose of innovating in the plant protein space. So it's not just protein chemistry or product development, but it's also, we're looking at nutrition, we're looking at breeding, we're looking at whether it's animal nutrition or human nutrition, toxicology, economics, informatics. It really is a bunch of interdisciplinary fields that need to come together, and we do have experts at the University of Minnesota. Also, when we talk about coming together to grow research, the tools that we have are infinite at the University of Minnesota. We do have our centers of excellence or expertise of analytical centers, or even like centers of excellence like sensory center or encapsulation center. But we also have our pilot plant where we can do trials to see feasibility for industry. And utilize all of our analytical centers in the process, as well as our own labs that have high-end instrumentation. one of our main focus is also to educate our next scientists or future hires for industry. So in the process of having these research initiatives, we are training the future scientists or the future hires. So that is one main focus also. Our research is mostly conducted by graduate student and postdoctoral researchers. So partnering with industry is key. So the reason we say that is we really need to hear from them. We really need to address their challenges, their opportunities, so that we become relevant. So their involvement is key. And their involvement also in a sense that they're willing to exchange knowledge. They're willing to work with us at a pre-competitive level so that we can produce the basic research that is needed for innovation. So the way it is designed, the research is pre-competitive. That means the basic type of research. So funding for that comes from industry contributions or membership. So they can come from membership dollars or contributions from their foundations. Like, for example, the CHARACTERIZATION Foundation, Corporate Giving Foundation, has committed 5 years of support in terms of fellowships to do research in this space. They're not members, but they're contributors, they're supporters. So other other types of funding that comes through for the pre-competitive bucket, it is from private investors, foundations, as we just said, and also state, federal funding and other types of funding. So in order to get enough funding to do research, we're not only seeking membership dollars, but other venues as well. And then so far, we've gotten about 1.2 million in funds, not just from membership, but from other sources, and I will give examples later. And we are right now have pending of about $1 million in pending applications. So, with that said, we also do sponsored research. So if any of our industry partners have a specific research that they have interest in IP, they can also do that with us under a specific contract, different from the consortium contract, where they can choose their IP plan if something comes out of that package. So it is an open bucket as well for industry to utilize the center. So we've grown so much in a very short period of time, and currently we have 16 members at different levels. Mostly larger companies are at partner level, more involvement, more contribution, and then smaller companies are at associate membership level. We do have companies that choose to start with associate for a year to kind of see if this is working for them. General Mills, for example, started an associate, and within their first year, they found value and converted to partner. We're hoping Coca-Cola will do the same as well. As for the rest of associate members, they are smaller companies, so that's the level for them. So even during quarantine, we were active and we gained 2 members since March. And we are in the process of membership agreement with 2 other big companies that we're excited about. And we will be soon 18 members and growing. And we do have collaborators from across the nation as well as international. Our collaborators, some of them provide in-kind time, like AURI provide in-kind time to use their facilities. CFANS Giving Foundation gave us their support. Different international, like Improve is France, located in France, and it is a protein research company, so we get their perspective. The CEO is serving on our executive board. Similarly, Wageningen University and Research, we have the protein manager for the protein program on our executive board as well to get that perspective. and we have representation from Canada as well. And we do have other supporters. For example, the Good Food Institute just funded us for a grant as well to work on meat alternative research. So our supporters, they support us in different ways. They advertise for us, and they span different perspectives, national and international. We have our technical committee, and it's represented representation is from our partner companies, the bigger companies. So they take part in the decision making with us in terms of research. So that's where the partnership comes from, where we grow together and we innovate together and choose the research topics with input from industry. Our executive board gives us our perspective on goals and mission and recruitment of other companies and advice, and also final funding decisions. And also, as you can see, that we have representation from international and national representation on our board. Now, coming to our research board, it's growing. We do have, as of now, 21 interdisciplinary researchers from across the university and also from other institutions. And the expertise spans food science, chemistry, metabolites, nutrition, breeding, engineering, flavor chemistry, sensory, more breeding, different aspects of breeding, nutrition. So as of now, we do have a good diverse group, but we invite others to join from different disciplines or complementary disciplines. In terms of events, we had our first protein basics short course. It was last September. We were hoping to hold it every year, but we had to cancel it this year. But last year we held it. We had great representation. We had lecture-based and demonstration and hands-on activities for our participants. It was very well received. Our first annual research spotlight meeting, we held it last October. We had, again, great representation. We presented our research that's coming out from the center, as well as highlighting research done elsewhere, but still relevant. We had a keynote speaker from Bethany University. And research, for instance, talking about the research in the meat alternative space. We've been active with initiating projects. So far, we had 2 rounds for proposals, and the first round we funded 2 projects looking at non-thermal processing to enhance pea protein structure and functional using cold plasma, looking at hemp and the different protein quality within different lines of hemp, and that is to initiate a breeding program that would breed for high protein quality and functionality in hemp. Looking at pennycress as a potential source of not just oil but protein, and looking at ways to breed for improved flavor and protein extractability and functionality. Again, there's an effort in having a pea breeding program here at the University of Minnesota, and in order to do that, we have to do some basic research to look at what do we want to breed for, what protein components we want to breed for. So there's some basic research that needs to be done first to get us there, as well as looking at flavor and interaction with plant protein. So these are the 5 projects that are currently going on directly from the funds of the center. Like I said, we don't only seek membership dollars, we seek other dollars to address our mission on our research goals, and we just got funded from the Good Food Institute. 3 interdisciplinary researchers from the center put in a grant to look at how do we texturize proteins from pulses to mimic a chicken-like texture, and looking at physical and sensory aspects. We submitted also to FFAR, and this was in addressing or in response to the plant protein enhancement project that they have. And here we are focused again on developing methodology in germ plants to enhance functionality and nutrition quality of pea protein, again, an initiative to start a pea protein breeding program or pea breeding program here at the University of Minnesota. So we had 5 interdisciplinary researchers, and we requested a little bit over $1 million. We will soon hear news, hopefully positive news. We were asked for revisions, and we submitted the revisions, and hoping that we'll get a positive response. So to end up, I'm just going to give you a few of research examples really quickly here of what we do, but on a high level. We look at optimizing extraction methodologies, and this is for enhancing pea protein viability because we still have limitations. So we're looking at ways to extract the protein while we maintain functionality as well as flavor. So we look at industry feasible methodology to enhance functionality and also reduce flavor. Looking at ways to functionalize the pea protein by different mechanisms as well. And these projects are not only funded by Plant Protein Innovation Center, but also by USDA ARS. Just an example of looking at functionality using enhancing solubility of pea protein by different methods. So remember, pea protein solubility is really low, so here's a commercial pea protein with very low solubility. And looking at our ways of extracting the protein, we were able to enhance solubility 4 times. Functionalizing it by hydrolysis, we improved solubility by 6 times. Fractionating into different components, we also increased it by about 8 times. And another technology where we functionalize the pea protein by glycation, we brought it to be similar to whey protein by 100% solubility at the acidic pH. So what else we're looking at, what other ways we can functionalize for other applications, we're looking at for us. Well, plasma is the 4th state of matter, so it is the ionized gas. And it is used in industry. It's feasible, it's easy to use, and it is used for surface modification and production of ozone for water disinfection, and it's been investigated for other purposes as well. But we're looking at it to a functionalized pea protein. And just to give you a quick look here, the red box here indicate in the center high molecular weight proteins. So by utilizing plasma under different conditions, we were able to generate high molecular weight proteins. And these high molecular weight proteins are necessary if we want to texturize the protein to mimic meat-like texture. So these, like pea protein does not have high molecular weight proteins initially, like soy or gluten. So by producing these high molecular weight proteins, we could potentially have a better or more texturizable product for meat application. Camelina and pennycress, this is also an ongoing initiative to look at how we can extract them from a complex matrix, looking at their structure and functionality, how we can enhance the functionality, looking at the protein nutritional quality and flavor, and also looking at crop diversity. And this work is being supported by different funding sources. Just here, a very quick example on color. We start with a really dark, small pennycress seeds, and we extract the oil. Then we remove additional oil by hexane, and then we produce 2 different types of protein ingredients using different methodologies. And we work to get lighter color as possible, as less of flavor as possible. And here's as a reference the soy protein isolate and its color. So we're working to get acceptable color, acceptable flavor, acceptable functionality, utilizing different extraction procedures. This is just a quick example. We're also looking at flavor by doing mass spectrometry analysis, where we look to identify flavor components in the seed, what happens to them in the meal, what happens to the flavor components in the final protein ingredient. So we monitor them across the processing chain. And we not only characterize the compounds trying to understand what they are by mass spectrometry, but we also couple it with sniffing. So we use GC olfactometry, where the gas chromatography, you have the eluent coming off of the gas chromatography column. It goes split into MS and then split to a sniffing board. And as the compound leaves the column, it gets detected by MS and it gets given a characteristic flavor associated with it. So main takeaways: demand for plant proteins deep and long term. We have challenges, but yet we have room for improvement, and hence we are working on those all sorts of interdisciplinary research to get there. So the research is ongoing, much needed, and to address these challenges and also to find opportunities. So the center will not only bring economic gain to the industry, but will also address the consumer desire for nutritious and healthy food, aiming to have a positive impact on the environment by seeking and utilizing sustainable crops, providing additional sources of protein for the growing population, and provide revenue to farmers in the process. So if you are a researcher, if you are an industry representative, government agent, crop association, join us, partner with us, so that we can together change the landscape of plant protein in the future, or for the future. So I'll end with thanking everybody for your attention, and also recognizing my research team, and a shout out for my manager of operations for the Plant Protein Innovation Center that helps with the growth of the center. That's it. I will end here and hopefully take some questions.
Thank you so much, Pam. Thanks for taking the time to be with us and for your presentation. We have a number of questions in the Q&A and chat windows, so we will start from the first one that came in. And you can keep your screen up if you'd like, if there's anything you want to go back to. So the first question that came in was, how is pea protein different than chickpea protein and potato protein?
Okay, thank you for the question. So chickpea protein is another pulse and a legume. There are a lot of similarity and homology within the different pulses, but it is less researched than pea protein. So there are companies, like we have Nutriati, for example, is one of our partner companies that are producing chickpea protein concentrate, and we are working with them to characterize their concentrate and compare it to pea protein and other plant proteins. Potato protein is a completely different category than pulses. Potato protein usually comes as a byproduct from production of starch, and it is potato protein is protein in potatoes is very, very low in concentration, so it's not a viable ingredient for a big market, but it is being looked at closely in Europe, and it does have so far acceptable nutrition, and it's highly soluble protein, but it really has very different characteristics than pulses.
Thank you. The next question is, what's the price comparison between plant-based protein and traditional protein?
I don't have the figures per se, but for example, if you take whey protein, it's more expensive than soy protein and potentially pea protein, just because of production, the way it's produced and processed adds premium to it. But I don't have exactly figures for you right now on top of my head.
Thank you. Okay, the next question is, do you think the growing demand for plant-based proteins will significantly shape what farmers plant, short-term and long-term?
Yes, that's a very good question, and absolutely. With more interest in plant protein and trying to figure out ways to feed the growing population, farming systems will potentially change to accommodate that. But what we're trying to accomplish is making sure that the farmer does not incur a lot of cost, energy, and low energy, low fertilizers, so that we can have a cropping system that allows for production of utilization of the land more efficiently and production of more of these plant-based or protein-based crops. So if we look at crop rotation, that would help a lot to utilize these crops that are short season. They keep the land covered, they maintain the nutrients in the soil, so that we benefit from having them, and at the same time the farmer benefit from ending with a crop that they can get seed or grain out of and sell as well and get profit to cover their cost of planting and utilization. So yeah, we're definitely going to see changes on the land and changes in farming and changes in what farmers will go for. But again, there's a lot of research that needs to be done to ensure that these systems will be successful and we have good and sustainable and abundant supply.
Thank you. The next question is, does the PDCAAS score change depending on how and where a pulse is grown in terms of conventional versus regenerative agriculture practices, and where geographically a pulse is grown?
Yes, pulses are grown mostly in the northern regions where you have really some cool environments to sustain their growth. So they require a little bit of cool environment, and they don't require a lot of, they require water, but they don't require a lot of water where they have to be soaked in water. The PPIC, which is the nutritional value that we count on to determine the nutritional quality of the protein, yes, it is impacted by environment. It is impacted by the soil composition, because that would impact the nitrogen level in the soil and how the nitrogen is used by the plant. So you end up having different protein profiles, slightly different amino acid composition, and therefore you end up with different nutritional quality. So it is very important. That's why part of the research we look at crop diversity, and it's not just by looking at different varieties, but also looking at different growing locations and different growing conditions. So it does impact, and this is an important research that needs to be looked at in terms of changes in the protein quality based on variety, based on location, and based on soil characteristics.
Thank you. We had a question. All of the proteins you described are from plant seeds. Do you see a role of plant proteins from foliage in new food products? These may have better solubility than seed proteins.
Foliage. I'm not familiar with this term. Are we talking? Sorry, I'm not familiar with the foliage term.
Okay, maybe we can hop to the next question then, which is, do we worry about processes like glycation to improve pea protein solubility, decreasing the digestibility of the protein source? This
Yes.
in turn decreases the PDCAAS score.
Yeah, this is an excellent question. Any processing really will incur changes in PDCAS. Sometimes the changes are positive, sometimes the changes are negative. So sometimes mild heat treatment, for example, enhance digestibility by just opening up the protein structure so that the digestive enzyme can reach certain peptide regions and cut. So sometimes excessive processing, high thermal treatment would cause polymerization of the protein and then reduction in the ability to digest, and therefore reduction in PDCAS. Now, in terms of glycation, this is a very important area of research, and there's a lot of controversy here that some research have shown decreased digestibility, some research has shown increased digestibility with glycation. And it all depends on the conditions that were applied during that process. So from a research I've conducted in my lab, under the conditions I've used, actually digestibility increased by about 9 to 12%. So it really depends, again, on the starting protein, on the conditions used, and then also when we look at the reaction that happens during glycation, what amino acids are involved. Usually lysine is mostly involved in this reaction, and it is an essential amino acid. But if we start with a protein that is high in lysine and you block a couple of lysine groups, then you won't be really impacted. But the PDGAS won't be that much impacted. But if you start with a protein, let's say gluten protein or grain source protein that's already low in lysine and you want to implement glycation, then you definitely are going to jeopardize an essential amino acid and reduce your PDGAS.
Thank you. All right, I think we have time for one more question, so we'll hop to this last one here. In the past year, there seems to be a battle between meat companies and small plant protein companies. In fact, a lot of the plant companies have been bought by the meat companies. Where do you see this going?
Yes, it's not just the meat company, not meat-based industry, it's also the dairy-based industry and the milk producers and the whey protein and casein producers. They're all facing this challenge right now with the plant protein gaining that much traction. So there is a lot of concern from meat and dairy producers and commodity groups. Also, there are concerns with the soybean production and utilization as well, although it's plant-based protein, but trying to go away from soy is a trend right now, and industry is seeking other than soy, so that's potentially an issue. So how it's going to manifest and unfold is really yet to be observed, but definitely the trend is going towards plant protein. And those meat producers, meat-based producers, and dairy protein producers, what they are concerned about is not only having different protein ingredients, but also different products altogether, like having milk alternative, oat milk, almond milk, and all sorts of different types of milk that is competing with the actual dairy milk. So that is potentially another area of concern where these meat replacers, dairy replacers are finding ways in the market. But what they are probably hoping for is maybe finding kind of a common ground where people look at blending. Like if you blend animal-based and plant-based, so you can increase utilization of plant-based, but you're still utilizing animal-based protein, still getting the nutrition that you want and getting the functionality, getting the flavor, and yet incorporating plant protein as well in your diet. So there are a lot of, if you go to conferences with a focus on protein, there are a lot of sessions that are just trying to address that particular issue, where we're going in terms of animal-based, what's the future of that industry, and how the plant protein is going to take over the world. So I think this is the continued discussion, and more will unfold.